this is Meera and I welcome you all to my YouTube channel. Today we will discuss how to find centroid of the area of an unequal eye section. I am going to give you in detail step-by-step procedure to solve example and a tip to solve this kind of examples very quickly in last section of the video. But before we begin, I recommend you to watch my video on basic concepts of center of gravity and centroid so that it will be easier to solve numerical. You can find video in I section above or a link in the description box below. So let's begin. Suppose we are designing a warehouse made up of different steel I sections. The top chord or rafter is made up of uneven I sections and we want to find out the centroid of its cross-sectional area. Let's say some of the dimensions of this section are known to us, like top flange is 30 cm by 5 cm, bottom flange is 20 cm by 5 cm, wave thickness is 5 cm and overall depth is 30 cm. Now, the very first step is to locate the reference axis and dimensions and find out all missing dimensions. Place x-axis at the bottommost plane of section and y-axis at the leftmost section. We will show all dimensions on the cross section itself for convenience. Top flange is 30 cm by 5 cm, which means that width of this flange is 30 cm and height is 5 cm. Similarly, bottom flange is 20 cm by 5 cm, so width of this flange is 20 cm and height is 5 cm. Wave thickness is 5 cm and overall depth is 30 cm. Now check for any missing data of width or height. Here only one dimension is missing and that is height of wave. We can find it out by subtracting upper and lower flange height from overall depth. That is, overall depth of 30 cm minus 5 cm of top flange minus 5 cm of bottom flange equals to 20 cm. Next step is to divide the whole area into more basic shapes, whose centroid locations are known to us. I have mentioned in my previous video that centroid of some shapes are given in reference books like triangle, rectangle, half circle, etc. So you can directly memorize this and use in numerical to avoid tedious and lengthy calculations. For this problem, we will divide it into rectangles. You can divide the area as per your convenience like this or this. Centroid coordinates will be same in each case. You can try it yourself for any kind of divisions, but here we will try to make it as simple as possible to simplify calculations. So let's divide this I section in 3 rectangles like this. Next one is an important step where all calculations to find out required data will be made. Before we start calculations, let me quickly remind you the equations to find out x coordinate and y coordinate of centroid. X coordinate is equals to sigma AIXI divided by total area and y coordinate is sigma AIYI divided by total area. So to find out centroid, we'll have to find out area, x coordinate and y coordinate of all individual divisions denoted by I. In our case, there are 3 divisions and all of them are rectangles. So in general, area of rectangle is width multiplied by depth and centroid coordinates are b by 2 and d by 2 depending on the position of rectangle. Also here all dimensions are in centimeter. So unit of area will be centimeter square and unit of x and y coordinates will be centimeter. Now let's find it out for rectangle number 1 or the bottom flange. Right now we will just focus on bottom flange and ignore other two rectangles. Locate centroid and dimensions of rectangle number 1. Okay, so area of rectangle 1 is 20 cm multiplied by 5 cm, that is 100 cm square. The most important step is to find out x and y coordinates of individual shapes. If you know how to find it correctly, problem of centroid is just a piece of cake. Cake. Anyways, so now as we know coordinates of rectangle are width by 2 and height by 2, x coordinate of rectangle 1 is distance in x direction, which is 20 divided by 2, that is 10 centimeter, and y coordinate is distance in y direction, which is 5 divided by 2, that is 2.5 centimeter. But this method can be applied only if reference axis is placed at this location. But it is not the case. Location of y-axis is some distance away from rectangle 1. So, a little change in coordinates will be necessary. So to find x coordinate, we have to add this distance from reference axis to the previously found coordinates of shape. This we can find out using dimension of top flange. Half of top flange is 15 cm and half of bottom flange is 10 cm. If we subtract these dimensions, we get 5 cm distance from y-axis. Now area is same. Final x coordinate x1 will be 15 cm and y coordinate y1 will be same as x-axis is touching the bottom flange. We will repeat step number 3 for other two rectangles. So first we will highlight rectangle 2, that is web, and locate centroid and dimensions. Now area of rectangle 2 is 5 cm width into 20 cm height, which is equal to 100 cm square. X and y coordinates for rectangle in general are width by 2, that is 5 by 2 is equals to 2.5 cm, and height by 2, that is 20 by 2 is equals to 10 centimeters. Again, these individual coordinates of rectangle are for this location of x and y axis, but reference axis are some distance away from rectangle 2. So we have to add these extra distances to previously found coordinates of shape. Again, distance from y-axis we can find out using dimension of top flange. Half of top flange is 15 cm and half of web is 2.5 cm. If we subtract these dimensions, we get 12.5 cm distance from y-axis. Distance from x-axis is same as thickness of bottom flange, that is 5 cm. Now area is same. Final x coordinate x2 will be 12.5 plus 2.5 equals to 15 cm and y coordinate y2 will be 10 plus 5 equals to 15 cm. Now repeat step number 3 for rectangle 3 or top flange again. Highlight rectangle number 3 and locate centroid and dimensions. Now area of rectangle 3 is 30 cm width into 5 cm height, which is equals to 150 cm square. To find out x and y coordinates, in general, coordinates are width by 2, that is 30 by 2 is equals to 15 cm, and height by 2, that is 5 by 2 is equals to 2.5 cm. Again, these individual coordinates of rectangle are for this location of x and y axis, but reference axes are some distance away. So we have to add this extra distance to previously found coordinates of shape. We can find out by adding heights of rectangle 1 and rectangle 2, which is 20 cm plus 5 cm equals to 25 cm. Now again, area is same. Final x coordinate x3 will be same as x, that is 15 cm, as y axis is touching the plane. And y coordinate y3 will be 2.5 plus 25 equals to 27.5 cm. So that's it. Let's sum up all the data we have just calculated. We just need to input area x and y coordinates results in the equation of centroid of an area. So to find out x coordinate of centroid, we'll take moment of whole area with respect to y-axis, which will be equal to summation of moment of all individual areas. Or you can memorize this equation directly. So put all values and we will get x coordinate equals to 15 cm. Similarly, y coordinate of centroid can be found out by taking moment of whole area with respect to x-axis, which will be equal to summation of moment of all individual areas. So y coordinate is 16.78 cm. If you observe here, the value of x coordinate is same 15 cm for all rectangles. The reason behind this is that our I section is symmetric about y-axis. So to solve this kind of examples quickly, find x coordinate only once as centroid locations are same. Even you can take y-axis at middle point so that x coordinate will be 0 and just find out y coordinate using above method.